Inference versus training. Inference versus training. Inference versus training is the distinction between the phase where an AI model learns patterns from data and the phase where that already trained model is used to generate predictions or outputs. Think of training as the heavy learning process. The model repeatedly sees labeled examples, adjusts its internal weights, and gradually gets better at minimizing error. Inference is what happens after that learning is done, when you feed in new unseen inputs, and the model quickly returns a prediction, a score, or a generated response. A useful mental model is exam prep versus taking the exam. Training is like months of studying. You repeatedly work through practice problems, get feedback, and update what you know. Inference is the exam itself. Under time pressure, you read a new question and instantly apply what you already learned, without relearning the whole subject. The model's parameters are fixed at inference time. It is just applying them to new inputs as efficiently as possible. In a recommendation system or large language model, training happens offline on huge datasets using many GPUs, possibly for days or weeks. Once that model is trained, inference happens every time a user opens the app, types a query, or asks a question. The system loads the frozen weights and runs a forward pass to return a prediction in milliseconds or seconds. This is the same phase where techniques like inference optimization, covered in a separate video, focus on making responses faster and cheaper. This distinction matters because training is usually rare, expensive, and done by specialized teams, while inference runs constantly in production and must be fast, reliable, and cost-efficient. System design, hardware choices, and optimization strategies differ, depending on whether you are in the training phase or the inference phase. Remember, inference versus training. Training shapes the model's knowledge. Inference applies that knowledge to new inputs.